Welcome to this session just after the break, and this session is about HTTP 3. Whoever sees me for the first time, my name is Shadrin. I worked for NGINX for 5 years and a week. So now I will talk about something quite interesting, one of the primary topics that you were clicking on in that poll in the keynote, which is HTTP 3. Okay. So let's start with the first very important question. Who here thinks that this is the session about NGINX announcing HTTP 3 support in NGINX? Good. There is no exciting announcement in this session, which means if this was actually the reason for you to be here for the NGINX support for HTTP 3, there are other sessions happening right now. You can leave, and I will not be angry at you if you leave right now. If you're still here, you have to stick to the end. All right. First, we'll talk about a few general introductory things about the session, how to find the materials, and some other things around it. Then we'll dive a little bit deeper into the history of HTTP protocols, just to understand better on how this development came to be. We'll talk about the difference between the stacks of different protocols, and definitely the benefits, the great things that HTTP 3 would bring you there. But also, I wouldn't be Russian if I wouldn't talk a lot about the challenges of this and about the things on how this protocol would bring also a lot of complications to the different environments and the development of different systems. Well, as a result, we'll see somewhat of a cleaner picture on the view of different versions of the protocol. So once again, this is purely the protocol session. This is not the implementation of the protocol session. All right. I will put a few links right there on the website, which means all of those slides and other kind of information. You don't have to take pictures of the slides. Those are very easy to find. All right. First, let's take a look at the HTTP request and the HTTP response. And right now we're looking at the basic understanding of the HTTP semantics here. The request comes in, the request has the request line, the request method, different kinds of headers. It might have a request body with the data that we're sending to the server. Then the response comes back, and the response has the HTTP version, there is the status code, and also there are headers coming back with probably maybe with the response body coming down there as well. And the great things about the different versions of HTTP protocol is the concept of all of those items, all of those parts of the HTTP request and response, it still stays. And that HTTP semantics, the properties of HTTP request and response, they're just being translated into the different transport layers. Basically, it means in your application, when you want to send the response with a particular header, or if you're writing an HTTP client that's sending a request method and URLs of some sort, all of those things, they will be and they are supported across the versions of HTTP protocol. We're not losing the concept of a URL. We're not losing the concept of a header in any of the versions. All right. The historical bit about the protocols. The very first version, which is 0.9, year 1991, it's quite simple. This is basically what you use if you open a telnet connection on port 80 and just type in get/ and just hit enter. That's going to be the HTTP 0.9. Once you hit enter after get your URL, after that, you're not specifying any headers, any versions of the protocol. It just goes directly to the servers, and the server starts responding back immediately. No special connection handling, nothing. It's absolute simplicity of the protocol. And then further down the road, in year 1996, more functionality appeared in the protocol. The different HTTP headers appeared there, the different cache and headers, the things for supporting multiple languages, multiple char sets, and the protocol evolved into something more usable in that sense. There was a major update in 1999 with the HTTP version 1.1, which included things like HTTP keep alives, upgrades between the different types of protocol, the things along the line of content ranges, the things on different hosts on the same IP address, and so on. One of the things about HTTP 1.1 that was actually in the specification was HTTP pipelining. That thing actually allowed you to send multiple HTTP, respond to multiple HTTP requests at the same time. But that feature was never implemented by any major server or any browser, and basically got forgotten very quickly. And after that, after year 1999, there was basically a longer break in the development of the protocol. And we saw some new updates towards 2009 when Google introduced SPDY. SPDY protocol, that's the one that that's allowing you to put multiple HTTP requests and multiple HTTP responses within the same TCP connection. And it introduced the zipping, basically compressing the header data, not just the body data, and included the flow control features to manage all of those different streams within the same TCP connection. And that concept of SPDY protocol, which was almost immediately included in some other browsers, it evolved into the concept of HTTP 2 protocol. And HTTP 2 in 2015, they reorganized and re-engineered the concept of zipping the headers into a different method with the HPAC. They added the features for prioritization of the streams, and things like server push, which is another interesting item that we could talk about. And all of that functionality, all of that HTTP 2 enhancements, they were aimed towards serving better for the loaded websites over not very good internet connection. I did a few years ago, I did an interesting graph which was calculating what's the percentage performance benefit of HTTP 2 over HTTP 1, depending on the complexity of the page and on network latency. On an ideal network where you're not losing any packets, HTTP 2 starts becoming very preferable for use once your network latency goes over 50 or 60 milliseconds, and if you have 20 or more objects on the page. In that sense, you start receiving huge benefit where your actual page load time goes down by a factor of 2 or 3 or even 4. And those things, they become absolutely different if you start, if you have a problem with network packet loss. And the problem with that is that since you're now using just one TCP connection, once there is packet loss, your rate of TCP connection drops immediately and significantly. And as far as using HTTP 1, you had a multitude of different TCP connections going on, and some of other TCP connections which didn't receive a packet loss, they could take over the unused bandwidth. Okay, so we got something that seems a little bit better for ideal network, but we also immediately appear to have some problem with some non-ideal networks. In 2016, the usage of HTTP 2 was growing just single digits of percentage points. Today, we're looking at 35–40% of the websites already using HTTP 2 in their environments. That's a great growth, and NGINX was on the forefront of that growth since most of those websites which are using HTTP 2 today, most of them are served by NGINX web server. Okay, so here's a question. Who here uses HTTP 2 on the website? All right. And who here turned off HTTP 1? Nobody. That's what we would expect. It seems like, okay, we got a new version of the protocol. Let's turn off the old one. And you see where I'm going to that, why I'm talking so much about HTTP 2 once we get into the concept of HTTP 3. All right. So one of the great things about HTTP 1, the moment you turn it off, no bots will be able to access your websites. Most bots, including Google itself indexing your pages, they're still using HTTP 1 protocol on your website. This is the best anti-DDoS thing that could ever happen in the world. Just turn off HTTP 1, no bots, no DDoS. But probably you wouldn't do that because it also means no Google and no good bots. All right. Let's talk a little bit more about the stacks of different protocols. As you probably know from the synopsis of the talk or from whatever conversations in social media and the news, HTTP 3 protocol is based on UDP. And that's a huge deal. The things I was talking about in the sense of managing one or plenty of different TCP connections, it's in the concept of the UDP datagram, some of those challenges, they don't exist. The problem with that is since you have the level, since you have to work with the protocol from the level of just the pure transport of the UDP datagrams, it means as a server developer or as a client system developer, you have to think of all of those transport features that we were taken for granted in the TCP protocol and re-implement plenty of those into the UDP protocol. Okay, so we get to the points of getting the proper data rate that's coming through the wire. We get into the point of ramping it up. We need to handle packet loss. We need to handle the retransmission. We need to handle a number of other different things within the application layer of that protocol. Okay, handling that in application layer, it gives us one great thing and one that's not so great. The great thing about handling that functionality in application layer is that we can actually make it better. We can take all of those 30-something or 40 years of TCP protocol development, throw it away, and tell everybody that we're better than the 30 years of TCP developers, and make it something that is more current, that is more designed for the today's networking, for the current equipment, speeds, latencies, and such and such. And the problem with that is, what if we're not better? All right, that was a little bit of a downer there. We still think that we can implement a number of great things in the connectivity level for this protocol. And as Owen was telling us on stage in the keynote, if you open the Google web page using the Chrome browser, that's probably it's probably opening very, very quickly. All right. A couple of other things that we have within the protocol. One of the items is since we're using the lower level transport there, we're not relying on kernel to create those connections for us, to manage this for us. We're actually taking all of that into the user land. And taking and developing that in userland gives us an absolute control of how the basis of that HTTP3 connectivity would work. Next thing about HTTP3 is encryption is built in. It's in the spec. It's all right there. if we step back a little bit into the world of HTTP2, in the specification of HTTP2, it is actually possible to have it running without any encryption. You can have plain text HTTP2 according to the specification, but no browsers support it. All the browsers decided, as probably some decision they made internally in those browser companies, to only support HTTP2 with HTTP with TLS connection. Okay, so here they took it even further. They didn't. They put the encryption directly within the standard of the protocol. That's pretty new. Okay, so the next item is quite important. The concept of HTTP3 has something that's completely new. It's the connection ID parameter that comes in with every, basically with every packet. The great thing about the connection ID, it's something that's generated between the browser and the server. That's the server understanding what kind of connection ID is coming, but it is totally detached from the transport level. The same connection ID might show up on the server coming from different interfaces or through different routers or from seemingly different clients. What that means is when I take my phone and I download some web page or something, and then my Wi-Fi goes bad and phone starts connecting through 3G, that in HTTP3 is the part of the great benefits of it. It will continue, since the connection ID generated by the browser is going to be the same, the server shouldn't care how that connection ID gets to the server, and it should be able to continue serving me the web page or downloading the file while I'm switching the interfaces, networks, or the network routing or other things are going around that. Okay. This is not the only way of achieving something similar. There were different attempts in the world in achieving something like that. Some things related to SCTP or TCP multipath, they can be noted in that same sense. However, this one is taking it into the protocol standard and should be handled by the server and the client, regardless of that lower level, regardless of the lower level connectivity there. And the great thing about it, once again, since we don't rely on the kernel, we don't have to compile something into kernel for this feature to be supported. It's all in userland. It's all in the upper level protocol. There is no need to update your Ubuntu to version 26 in order to have that newest feature out there. You can have that same HTTP3 working on your probably current or next to current operating system. That gives an interesting idea on how the best and the newer things can actually be brought into the older enterprise systems. Well, I still sometimes see Red Hat 6 somewhere. All right, let's.
Connection ID, is it a layer 6 or layer 7?
Connection ID is an identifier that's defined between the client system and the server system, and it's put in every one of those HTTP3 frames, and the server should identify the client not by the IP addresses or ports, but rather by the connection ID. All right, let's talk about the different types of negotiation between the different HTTP protocols. And here we're looking at something interesting. First of all, and actually this is one of my favorite questions that I ask at the job interviews on how the protocol is being chosen between the client and the server. And let's look at the first item here. The first one is pretty simple. It's just the choice that we need to make between the HTTP and the HTTPS protocol in the standard sense of HTTP1, for example. And pretty often it's done with some of the 300 redirects, like 301 or 302, and we're just defining the HTTPS location header, and now the users can the users who chose first to connect to port 80, and the server knows that port 80 is not really something that that server is ready to serve something good on. They just send the response back with the ask to reconnect somewhere else. And that's the 300 redirects, which are being created with redundancy within the actual HTML page. This is the basis of sending the user somewhere else. Now the next item, and that's a fairly recent development, it's called the HTTP Strict Transport Security headers. HSTS headers are the ones which are supposed to be remembered by the browser. And once the browser remembers that a particular website only supports or only likes the connectivity through HTTPS, on the next attempts from the user to type in a URL, that web browser will immediately go to HTTPS protocol, will not try to connect to port 80, will only keep the connection encrypted. I'm not saying secure. Please note that. When I'm talking about TLS, I'm talking about encryption, not security. Those are different things. All right. The next thing on how to change protocols between the different HTTP or other protocols, it's the upgrade header. It's possible from the server perspective to send the upgrade header for the client to continue sending data using some other protocol than what was originally intended. For example, you can do it for something like WebSocket. When your JavaScript clients from the browser are connecting with WebSocket, they are using that kind of upgrade header procedure in order to ask the server to start sending data using a different protocol. And originally, upgrade header was something that was considered for the HTTP2 negotiation as well. When the clients were connecting with HTTP1, and now we needed to send some data over HTTP2, great, we just send the upgrade header, and now the client can continue doing that. That didn't fly for some reason. I actually don't know what the reason was, but that was not working and either removed or not included in the spec. And another thing is on how to negotiate the connectivity to HTTP2 was the TLS extensions such as NPN and ALPN. Those things are quite interesting, and they're actually quite simple. Before sending the real data, once the encryption was set up, even before the encryption was set up, it was possible to send some special identifiers of the supported protocol between the client and the server. Either client could ask to send data with HTTP2, or the server could present that the server prefers or knows HTTP2, so the client would be sending HTTP2 data immediately once encryption has been established. All right, those things were working well with the NPN extension and ALPN. But at some point, NPN extension got removed from the browser, starting with Google Chrome, and then others followed. And that triggered a lot of updates of OpenSSL versions with our users' environments and even with the operating system maintainers. Okay, now we're getting to another interesting point. We just changed the protocol negotiation somewhere on the layer 7, and now you have to replace almost the whole distro of your operating system to have that supported. You see where I'm going? With the protocols of older kind, with the things that are based on TCP, with the things like which use TLS that way, any change in that protocol level, it becomes an operational nightmare for the enterprise that is either stuck on an older system or just doesn't like to change. Well, in that sense, I think that one was a good thing. We actually got a lot of changes, a lot of updates with the more great functionality of the newer operating system. Many users upgraded NGINX to support all of those things correctly with the newer versions. It made internet faster and more secure. But it was some kind of a headache for plenty of enterprises to go from Red Hat 7.2 to Red Hat 7.4 or something like that. All right. Now let's talk about the change from HTTP1 or HTTP2 into HTTP3. And that's done with a different header called alt service. The difference between the previous negotiation methods and this one is that we actually have to change from the whole from the one transport layer to the completely different transport level, a completely different transport protocol. You cannot say, now please continue sending HTTP3 data over the same connection. There is no same connection. There is just a bunch of datagrams that are going to land into a completely different port and even possibly even in a different host name. The alt service header is the one where you can define your HTTP3 endpoint, and that HTTP3 endpoint must be defined also with the port. The MA parameter is the max age on how long the browser should remember that kind of setting further and later on. All right. Now we get to another point on that having a different port. Your HTTP3 protocol doesn't have to reside on the same ports 443 or port 80. You can actually move it out into some other UDP ports, and now it will be the task of the networking equipment to support and to pass all of that data correctly over the UDP protocol. Okay, so that was the bit about negotiation of the protocol. Now let's get a little bit further into the challenges between that, and I guess we have just about 10 minutes left. I wonder if I can cover the challenges of the protocol in 10 minutes. All right, let's take a look at the simple development system, probably similar to an NGINX instance installed on your laptop. The connectivity will look something like that. Yeah, it's just a client, there is just a server, I'm just connect to my 127.0.0.1, and hopefully I get some response from that server if I'm really lucky. And then I'm gonna set something up, just work with my telnet, work with my curl and other tools, very simple. But in a more realistic world, there might be some other box sitting between my client and my server. Probably that's going to be something related to maybe a load balancer, maybe some network router which is picky to what that router likes to pass or not. There might be some firewalls, proxies, and so on. So realistically speaking, your connectivity to your server is going to be looking something like that. Okay, what's the problem with that? Those different middle boxes, they are quite often managed by different companies, different departments, and those boxes often come from different vendors. And you cannot replace all of them with NGINX, because some of them will be the boxes that actually are lower level firewalls. Some of them might be routers which don't like particular protocols. Some of them might be the deep packet inspection boxes, which if they don't understand some kind of encryption, they're just going to close that connection, and our client will have to downgrade to HTTP1. So we're getting to the point that for worldwide adoption of HTTP3 protocol, all of the boxes that want to tap into that, to rate limit it, to understand the ports, the host names, to proxy things correctly, to load balance something, they all will have to talk HTTP3 in order for the protocol to be properly supported on the internet. And since this is a totally different transport level, totally different transport protocol, I suspect that it will take significantly longer for HTTP3 adoption to be worldwide and to achieve any significant levels than it happened with HTTP2. Well, as I'm saying, currently in 3 years of HTTP2 development, already about 40% of the internet websites are supporting it. Probably with HTTP3, that's going to be way slower because one of the things because of this problem, because of the middle boxes. All right. The other things about the middle boxes, they are related to the slower upgrade cycles in them. How often do you upgrade your internet router? Probably not every year, maybe even less frequently than every 5 years. And that upgrade cycle is bringing another set of challenges to that. Hardware is tuned for TCP protocols to understand the web. It's not really tuned for UDP and such. And the conversation between the different internet companies is not always as friendly as we want it to be. All right. Now, the other challenging part in HTTP 3 development, it comes from the point of view of our server engineers. And we have a few of our core developers of NGINX sitting right here. And they really like my presentation because I'm talking about their pain. And their pain in developing this protocol is going to be coming from different angles. It so happens that TCP stack in the kernel is currently more optimized than UDP. Funny enough, but those 40 years of development, they actually matter. And UDP, in some cases, is actually slower. Okay, that's one of the things. Now, the next one is we need to re-implement all of the, not all of the, but a lot of functionality of TCP, and we need to build it in basically at least the same or better way that it was designed in the TCP stack of the operating system. That is a huge body of work, and that needs to be done pretty quickly and very reliably. The security level of that development, not just the functionality, but performance and security, those are the keys for the server developers, and developing that functionality correctly will take a lot of time. And another item which is quite interesting is that UDP traffic is it's not as easy to process in a multiprocessing system, as you have to recombine all of those datagrams correctly and ideally send them to the correct worker processes of the system. In addition to that, we will get a more interesting, more complicated process of reloading of the configuration or restarting the worker processes when the connection is coming in flight. Those are huge nightmares of some of our engineers right now, but hopefully they will get it resolved soon. All right. Another item within the challenges part is the fact that the tooling for HTTP 3 protocol is not something that's been developed well or widely adopted. Well, with HTTP 1, especially without the SSL version, it's very simple. You just get telnet going, you get some curl commands in, you can see everything right there. The headers are plain text, I can understand whatever's coming in and out. Great. It's less easy, it's more complicated with HTTP 2. However, with HTTP 2, you're still using the same ports, the same TCP level. And once you either don't upgrade the connection to HTTP 2 and do your troubleshooting with the HTTP 1, or you can understand some of the things using already developed tooling, such as curl and other tools. So we have more ability to debug HTTP 2 and especially to debug HTTP 1 over the network. But with HTTP 3, the tools are almost non-existent at this sense. And looking into the bunch of encrypted UDP traffic is not that easy. And the rest of that is the visibility and monitoring, which goes even further than just the web server development, further into the load balancing boxes, into the routers, proxies, into all of those middle boxes which want to take a look at those UDP connections and figure out what those users are, how quickly a particular particular connection is working, how the servers are responding and such. Visibility and monitoring into HTTP 3 is another huge tooling challenge. All right, and the next item to that is the set of security challenges. As UDP protocol is not something that's being currently trusted on the internet, there were so many different security breaches related somewhat to different implementations over the UDP protocol. Some companies, some organizations started to block it on the levels where I think they shouldn't be blocking it. The other items in the security challenges, they relate to the different misconfigurations of the equipment and the design of security devices. We need to get more understanding into how that traffic would work. There is some bits of conspiracy theories on Google owning all of the internet connectivity with the Google Chrome browser, with the implementations and the RFCs, with the QUIC protocol development, with SPDY and HTTP 2 promotion, with the QUIC and HTTP 3 promotion, and so on. And also the protocol itself, since it's all userland, is going to be, there is a possibility to make changes to that protocol very rapidly, very quickly. And with all of those changes to the protocol, there is a higher attack surface than you would have over the more layered approach with TCP and HTTP protocol on top of TCP. All right, so I think we're almost out of time, and Scott is looking at me, and he's not going to let you ask too many questions. However, we're getting to the point that there are some implementations of HTTP 3 already existing in the world. You can look it up. They're right there. The QUIC working group, take a look at that page at GitHub, and feel free to ask maybe one question, please.
For one lucky person, and of course you can take the 5 minutes afterwards between talks to ask questions as well with Nick. Does anybody want to go first? First come, first served.
Cool, close the session.
Thank you very much.
All right, thank you so much.